In this video, we'll be looking at solving absolute value equations. Now, absolute value, we normally denote it like this. Let's say, for example, you have a number 4 and I ask you for the modulus of 4. Now, the term modulus, when it's used in mathematics, the meaning depends on the context. Now, in this context, for this topic, key topic we're doing, it's in the context of what we call absolute value. Now, what's it, for example, here? This is asking for the absolute value of 4. What's the absolute value of 4? The absolute value of 4 is the distance of 4 from 0 on the number line. So if you have a number line like that, alright, the absolute value of 4 is a distance between 0 and 4. So the absolute value of 4 is 4 units. An interesting thing about it is that the absolute value of minus 4 is also 4. And I think what distance is what we call a scalar quantity, meaning direction is not important. So if you're at 0 on the number line and you want to get to 4, it will take you 4 units. And if you want to get to positive 4, it's the same 4 units. So the absolute value of 4 is equal to 4, and the absolute value of minus 4 is also 4. Alright, so the absolute value is just the distance of the value from 0 on the number line. Alright, so the key thing to note that the absolute value for say 3 is 3, and the absolute value of minus 3 is the same thing. Good? And we define it, absolute value of x is equal to x, and that's when x is more than 0, and it's equal to minus x, and that's if x is less than 0. So in other words, if x is a positive number, as in the case here, if x is a positive number, 4, then the absolute value of 4 is 4. And if x is a negative number, as in the case here, is negative 4, then the absolute value is minus 4, which is still positive 4. Good? And put on the value. So if I ask for the absolute value of 7, I'm asking you, how far is 7 from 0 on the number line? Alright, so the absolute value of 7, because 7 is a positive number, so we say 7. And the absolute value of minus 7 is, according to this definition here, is minus 7, which is still positive 7. So whether we have a negative between these ticks here or a positive, the result is a positive value. Let's look at how we solve some equations now using the definition. So the first simple equation we look at, we're asked to solve the equation. The modulus of x, or the absolute value of x, is equal to 8. What are the possible values of x? And you can look and tell that one. So if the modulus of x is equal to 8, then either x is equal to 8 or x is equal to minus 8. Because if you put the modulus of 8 is positive 8, and the modulus of negative 8 is also 8. We'll call that number 1. Let's do another one. Let's say the modulus of x plus 1 is equal to 6. So again, whatever you have between the sticks here, between these strokes here, can either be, bracket there, this can either be 6 or it can be negative 6. Alright, because the modulus of 6 is 6 and the modulus of minus 6 is also 6. So whatever is between these strokes here has to be 6 or negative 6. So x plus 1 equal to 6. Solving that, subtract 1 from both sides, x equal to 6 minus 1, which is 5. Here, subtract 1 from both sides, x equal to minus 6 minus 1, which is minus 7. So the possible values of x are 5 and negative 7. And you can test it. If x is 5, here you'll have 5 plus 1. So you have a modulus of 6, which is 6. And if x is minus 7, what you'll have is negative 7 plus 1, which is negative 6. And the modulus of negative 6 is 6. Let's look at another way you can do question 2. Well, can do any of these questions as a matter of fact. Let's do question 2 again. The question was modulus of x plus 1 is equal to 6. One technique you could use is square both sides. So you square both sides. That will get rid of the modulus sign. So you square both sides. Now this, what we have in the bracket here can either be positive or negative. So you have x plus 1 square, and it's squared is definitely positive, right? So x plus 1 square equals 6 square. Now what's x plus 1 square? Just separate this. X plus 1 square means to multiply x plus 1 times itself, right? So it's x plus 1 times x plus 1. And 6 times 6, that's 36. So expand this. I get x square plus x, so that would be plus 2x. And the 1 times 1 gives me 1 equal to 36. And then we have a quadratic. So which means I can group the constants. So positive 1, subtract 36 from both sides. So this becomes 1 minus 36 equals 0. So I have x squared plus 2x minus 35. And I'll skip a couple steps here and factorize both sides. Now if I factorize this quadratic, what I'll have, remember positive 2 can be written as 7 minus 5, right? So x plus 7, x minus 5. And to test if this factorization is correct, we can just expand the bracket and we should get this quadratic here. So notice if you equate both brackets to 0, you will have x plus 7 is equal to 0. Now if x plus 7 is equal to 0, what is x? X will be negative 7, right? And if you equate x minus 5 to 0, when you solve, you get x equal to 5. So notice you get the same two solutions. You get the same, well, x plus 7 equals 0, it's negative 7, right? If you solve that, bring over 7. Alright, and x minus x. So notice the same solutions. Negative 7 and positive 5. Likewise, this was the first one. If you square both sides, you get x squared. Square 8, you get 64. This is x squared minus 64. That's x squared. That's a difference of 2 squares, right? That's x squared minus 8 squared. And if I factorize difference of squares, x minus 8, x plus 8. And if I equate both brackets to 0, x equal to 8. Equate x plus 8 to 0 and solve x equal negative 8. Alright? Let's look at another one.